Okay, here we're going to use the definition of the derivative to find the derivative of the cube root of x. For one thing, I'm going to rewrite this as x to the 1/3 power. And another thing before we get started, I'm going to end up using the difference of cubes formula. So if you have x cubed minus a cubed, then this can be factored as x minus a times x squared plus ax plus a squared. All right, now to the actual definition. So it's going to be the limit as x approaches a, and then the definition that I'm using is going to say f of x minus f of a over x minus a. So it'll be f of x, or x to the 1/3, minus f of a, which is a to the 1/3, over x minus a. Usually, when you've got something that's got a square root and a square root, you could use the conjugate. With cube root, it's not that simple. Thus, I'm going to use this formula over here. Although this formula over here is when you have something raised to the 3rd power. Well, what I can do is I can rewrite x as something to the 1/3 to the 3rd power. That's going to be x to the 1/3 raised to the 3rd. So it'll look like the limit as x approaches a, and then for the denominator, just take x, rewrite it as to the 1/3, then to the 3rd power. So this right here, if you were to simplify it, is the same as this x down here. Now do the same thing with a. So a to the 1/3, and then raise it to the 3rd power. And for the numerator, just recopy it. So the next thing to do is use this formula over here, where the x that's being raised to the 3rd is actually this x raised to the 1/3. So this part is going to say x to the 1/3, a to the 1/3, x to the 1/3 squared, etc. So the limit part, that stays there for each and every step. And then the denominator can be factored. So it's going to be x minus a, in this case becomes x to the 1/3 minus a to the 1/3. Then you have to square it. So it's going to be x to the 1/3 is squared. And then plus multiply the two things. So that's x to the 1/3 times a to the 1/3. And then finally square the a. So it's a to the 1/3 that's being squared. And then just recopy the numerator. Well, we finally get to the reason that I did that factoring, because now this x to the 1/3 minus a to the 1/3 will cancel this x to the 1/3 a to the minus a to the 1/3. And then what's left? Limit as x approaches a. The numerator now just has a 1. When you raise a power to a power, multiply. So this is going to be x to the 2/3. In here, I can't really simplify. And then this is also going to be to the 2/3 power, so plus a to the 2/3. And then finally, x approaches a. So this is going to become an a, and that's already an a. So then I don't have to write limit anymore. So it's going to be a to the 2/3 plus then a to the 1/3, and there was another a to the 1/3 plus another a to the 2/3. And then this is a to the 2/3, this is another a to the 2/3, and this is another a to the 2/3. That means we have, in the denominator, 3 of them. that are a to the 2/3. And then that should be the answer. Now over here on my scratch paper, I can check, because if I say the function is x to the 1/3, and I use the power rule, bring the 1/3 down in front and multiply, and then subtract 1 from the exponent. So that's going to leave a 1/3, and then this, when you subtract, is going to be x to the negative 2/3. And if you rewrite this so it doesn't have a negative exponent, that means that x to the 2/3 goes to the denominator. The 3 was already in the denominator. The 1 is in the numerator. And then this is the same as this. So we did the derivative correct. The other part is, why is it that the derivative at 0 does not exist? So that means if you were to substitute in 0 right here for a, that means you would have division by 0, which is undefined. All right, that's it.